Hello guys, it's Math Time Question and Answers bring to you another question from the Cameroon GCE board 2020 question 8. This question talks about sequences and series, and it says that the sum of the first n terms of a sequence is given by Sn equals to 2n squared minus n, where n belongs to a set of integers. A. Find the first three terms of the sequence, and B. State the type of sequence. So what they are saying is that they have given us the sum of the first n term to look for the first three terms, and we'll use these first three terms to look for or to state whether the sequence is an arithmetic progression or is a geometric progression. Now, for us to get the first three terms, we need to know what the sum of the first n term is all about. So the sum of the first n term simply means that if we have the first term, we are summing the first term plus what? Nothing. So the sum of the first term is the first term. The sum of the first two terms is the first term plus the second term. The sum of the first three terms is the first term plus the second term plus the third term. The sum of the first 5 terms will be the sum of the first term plus the second term plus the third term plus the third term plus the fourth term and plus the fifth term. So that's what they have computed to give us this general expression here for the sum of the first n term. So if I substitute 1 here, because the sum of the first term will be when n is 1, the first term, so we'll substitute it here to get the sum of the first term. If we substitute when n is 2, meaning we are looking for the sum of the first two terms, and so on and so forth. So to begin, we know that the sum of the first n term is 2n squared minus n. So let's get the sum of the first term. The sum of the first term is when n is 1. So in that case, we'll look for s of 1. So anywhere we see n, we put 1 in this expression. So we are going to have s of 1, which is 2 into 1 squared minus 1. So 2 into 1 squared, 1 squared is 1. 1 times 2 is 2, and 2 minus 1 is 1. So we are going to have s of 1 equals to 1. But as we already said, we know that the sum of the first term is the same as the first term, because we are not adding the first term to anything. So the sum of the first term is the same as the first term. So we mean that t1 is equals to 1, which we will call the first term. Okay, with this in mind, we are going to look for the sum of the first two terms. So when n is 2, we have the sum of the first two terms. Again, we go into this expression, anywhere we see n, we put 2, and we are going to have s of 2 equals to 2 into 2 squared minus 2. So 2 times 2, or 2 squared, is 4, and 4 times 2 minus 2 will give us the sum of the first two terms. Now the sum of the first two terms will be 4 times 2, which is 8, minus 2, which is 6. So the sum of the first two terms is 6. But s2, as we already know, is the sum of the first term plus the second term. So we imply that s2 is equals to t1, which is the first term, plus the second term. So when we take t1 to the other side, we are going to have t2, which is the second term, minus the sum of the first two terms minus the first term. So we are going to have t2, the second term, to be this. Now t2 will be equals to the sum of the first two terms, which is 2, minus the first term, which is 1. So we are going to have t2 to be equals to 6 minus 1, which is 5. With this method, we are also going to substitute when n is 3 to get the sum of the first three terms. So we are going to have s of 3, s3, equals to 2 into 3 squared minus 3. And 3 squared is 9. So we are going to have 2 times 9 minus 3. And 2 times 9 is 18. 18 minus 3 is 15. So we are going to have S3 equals to 15. But we already know that S3 is not the third term, is the sum of the first three terms, meaning S3 is equals to T1 the first term plus T2 the second term plus T3 the third term. So in this case we already know that T1 plus T2 is the sum of the first two terms as we have it here. So in that case we'll replace T1 plus T2 by S2. So we are going to have the sum of the first third term equals to S2 plus T2. So we are going to take S2 to the other side, it will become negative. So T3 will be equals to the sum of the first three terms minus the sum of the first two terms, and that is going to give us 15 minus 6, which is equals to 9. So in that case we therefore say that the first three terms will be 1, 5 and 9. So those are the first three terms. Now using these first three terms we need to look for or state the type of sequence that we have. As we said earlier, we can have two types of sequence. We can either have a geometric sequence or we can have an arithmetic progression sequence. So for a geometric progression, we are going to have what we call a common ratio, and this common ratio is obtained by the third term divided by the second term must be equals to the second term divided by the first term. So if this is true, then we have a common ratio, and then we can conclude that the sequence is a GP, which is a geometric progression. So let's check. The third term is 9, the second term is 5, which is supposed to be equals to the second term 5 divided by the first term 1. Is that true? No. Since it's not true, then we say that this sequence is not a geometric progression. So let's try if this sequence is an arithmetic progression. How then do we go about this? We go about this by looking for what we call the common difference. For us to have the common difference, we say that the third term of the progression minus the second term of the progression must be equal to the second term of the progression minus the first term. If this is true, then we have what we call a common difference, and therefore we can conclude that this sequence is an arithmetic progression. So let's try. We know the third term to be 9, the second term to be 5, and the first term to be 1. So 9 minus 5 must be equal to 5 minus 1. Is that true? 9 minus 5 is 4 and 5 minus 1 is 4. So we say that the common difference of that progression is 4. Since we have the common difference, we then conclude that the sequence is an AP, which is an arithmetic progression. So guys, that's how we handle problems similar to this in sequences and series. Don't forget to like, subscribe and share the video. Also hit on the notification bell for more upcoming videos, and don't forget to comment on the comment sections on videos you want us to on questions you want us to make videos about. So stay with me and remain blessed. Bye bye.